In this lesson, you will learn to prove that certain quadrilaterals are also parallelograms. Now in the last lesson, we learned different properties of a parallelogram. So we learned that first of all, that if we have a parallelogram, then the opposite sides are parallel. We learned the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, as well as the diagonals will bisect each other. Now in this lesson, we're doing basically the same thing, except we're taking the converse of each statement, where if we change the if and the then part of the statement, we would then have statements that said, if the opposite sides are parallel, then the shape is a parallelogram. Or if both pairs of opposite sides are congruent, then we have a parallelogram. Or if both angles are congruent, then quadrilateral is also a parallelogram. And if the diagonals bisect each other, then we have a parallelogram. So all we did was we just switched the if and the then statement, where now we have different ways to show that we have a parallelogram. In addition to these four ways, we have a fifth way that we can add to this, and that is that if one pair of opposite sides are both congruent and parallel, then the quadrilateral would also be a parallelogram. So we have each of these five ways to show that something is a parallelogram. And the rest of this lesson will use these different properties to try to prove whether or not we have a parallelogram. So here is example 1. We're told that MT is parallel to AH. So MT is parallel to AH. And then MA, up here on the top, is parallel to TH. So the question is, does this make a parallelogram? Well, a parallelogram by definition needs the opposite sides both being parallel. And that is what we have. So therefore, yes, this would be a parallelogram because both pair of opposite sides are parallel. Now, what if we only knew that MT was parallel with AH? So MT and AH are parallel. Well, this would be inconclusive because we don't know if MA and TH are parallel. So therefore, no, we cannot prove that we have a parallelogram because we only have one pair of opposite sides that are parallel. And we need both to be parallel to be a parallelogram. Next example, same picture. You're told that MT is equal to AH. So MT and AH are equal. And MA is equal to TH. And the question is, would this be a parallelogram? And the answer would be yes, because we have both pair of opposite sides that are congruent. And by definition, that would give us a parallelogram. And what if we were told that we just had MT equaling AH? So we did not know that these two, the top and the bottom, were congruent. Well, if this were the case, we would not know if there's a parallelogram because only one pair of opposite sides are congruent, and we need two pair. Here's another example. We're told that angle TMA, right here, is congruent to angle THA, right over here. And then angle MTH is congruent to angle HAM. And the question is, do we have a parallelogram or not? And the answer would be yes, because we have both pair of opposite angles being congruent. If, however, you are told that angle TMA is congruent to THA, and that was it, this is not enough information, because we only have one pair of opposite angles, but we need both pair of opposite angles to be congruent in order to have a parallelogram. The next example, we have MO equals OH and TO equals OA. So MO and OH are equal, and then TO and then OA are equal. So notice that we have both diagonals being bisected. So therefore, yes, we would have a parallelogram because we have both diagonals bisected. Now the next question would be, what if all we had was that MO is equal to OH? So we did not know that TO and OA were equal. Well, if that is all you knew, that is not enough information to conclude that we have a parallelogram, because only one diagonal is bisected, and to prove that we have a parallelogram, we need both diagonals being bisected. And lastly, we have MT is parallel to AH, and MT is equal to AH as well. And the question is, do we have a parallelogram or not? And this would be that last way to prove that we have a parallelogram. And yes, we would, because one pair of sides are both congruent and parallel. And that concludes our lesson for today. We will see you next time.